You got a friend in me. You got a friend in me. When the road looks rough ahead and you're miles and miles from your nice warm bed, you just remember what your old past said. Boy, you got a friend in me.
Good morning, Gallup Hill School.
Would everyone please stand for the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Would everyone please remain standing for a moment of silence?
Good morning, Colonel. Would everyone please raise their right hand and repeat the BARC pledge with us? I promise to be accepting, responsible, and kind. Everyone may now be seated.
It's now time for a morning announcement.
Tomorrow is Tie-Dye Day. Peace, love, and good vibes. Don't forget your food items.
The breakfast table is probably the last place you'd expect to find cool physics, but there is some awesome science happening right here, and you've probably seen it lots of times without even realizing it. Ever notice how cereal tends to stick together in the middle of the bowl, or it clumps to the edges? That makes it easy to eat. But why does it happen? We see the same clumpage with other objects too. Paper clips, thumbtacks, even bubbles in a beverage will snap together. Maybe you've noticed this, but scientists didn't fully understand what was going on until 2005, when a pair of mathematicians decided to hit the lab, hit the kitchen, and hit the books. And what they found is cool. I'm Super Cereal. Check this out. Breakfast cereal is less dense than water, and milk is mostly water. It's buoyant. It weighs less than the milk it displaces. And that force of buoyancy pushes up on each ring until it matches the downward force of gravity. This interaction holds the Cheerios at the surface of the liquid, like little toasty rafts drifting together on top of a sea of cereal milk. It's a really complicated way of saying cereal floats. But look closely at where the cereal meets the liquid. It's curved up. The same thing happens at the edge of the container, thanks to the meniscus effect. Water molecules are sticky, they're attracted to each other, but they're even more attracted to the edges of your bowl or glass, or to the edge of the cereal itself. That adhesion forms a U shape wherever the liquid meets an edge. A buoyant object will always be pushed up the liquid to the highest point on a meniscus. That's what makes them stick to the edge, and what causes the Cheerios to become Cheery Amigos. Any two nearby O's are pushed to a high point between them, and clumps are pushed toward the overall highest point in the bowl around the edge. Let's try something denser. I don't recommend eating paper clips, but toss them in water and they sink. Place them carefully though, and you can get them to float. They're too dense to be buoyant. They float because of surface tension. Water molecules like to stick to each other so much they can behave like a membrane that's strong enough to hold up tiny things. Now let's try it with these thumbtacks. Like the paper clips, you can see that they're pushing the membrane down, just not hard enough to break through. If I place another one nearby, watch what happens. They're attracted to each other, just like the Cheerios, but the water around each one is curving down. Instead of climbing up the water like the cereal did, they fall into each other's sinkhole. We can mess this whole scenario up just by adding soap. The chemical properties of soap lower the surface tension of water, so anything relying on surface tension to stay afloat will sink. But buoyant objects don't rely on surface tension, so they continue surfing the meniscus. Now, the first time I did this, I wondered if the tacks were being pulled together by static attraction on the plastic coating or something. So I put in just the plastic bit to see. But instead of being pulled towards the tack, something strange happens. They repel each other. The same thing happens with Cheerios and a paperclip. That's because light floaty objects run away from the low points caused by the heavy objects. A buoyant object will always repel something held up by surface tension's stretchy membrane. Just to be clear, you should never put thumbtacks in your cereal, but this is what would happen if you did. All of this made me wonder, what could happen if we could reverse the direction of water's meniscus? I coated this glass with a hydrophobic coating that does just that. When I put thumbtacks on top of the water in here, they floated to the edge instead of the center. And that buoyant object did the opposite. It floated to the middle. So that's cool and all, but does the physics of cereal clumping actually matter in the real world? It does if you're a tiny insect. Take water striders. These pond skaters are nature's Cheerios. They float so well that even a load 15 times their body weight won't make them sink. They can even jump on water. Tiny hairs on their legs trap air bubbles and increase their buoyancy. They're basically wearing swim floaties on their feet. Other aquatic insects like water treaders exploit surface tension, just like thumbtacks and paper clips. But they get in trouble when it's time to get out. Gravity is pushing them into the depressions under their feet, but they've come up with a clever way to climb the meniscus. A running start doesn't work, but by arching their bodies and lifting their front and back ends, the bugs curve the water up and they're pulled to the edge just like the Cheerios were. They're carried uphill by a physics-powered water escalator. That's pretty cool. If you can find science like this at breakfast, imagine what else you might see the rest of the day. Try this for yourself and see what other floating objects you can get to attract or repel. Leave a comment and let me know what you find. And if you see any cool physics in everyday life I should check out in a future video, let me know. Stay curious.
That's all for our program today. Thanks for listening.
Thanks, everyone. Have a great day. Bye!